Hello, I'm going to be demonstrating a simple Spring Boot application that consists of two services. They're deployed to Kubernetes and instrumented using the OpenTracing API. The OpenTracing instrumentation is actually going to be used to capture tracing information which is reported to the Jaeger backend system, but also application metrics that are going to be reported to Prometheus. The example I'm going to be showing can be found at this at GitHub repo. So first I'm going to have a look at the Kubernetes dashboard that shows the two services, the account manager and the order manager. There's the Jaeger OpenTracing backend there. We're going to be displaying the metrics showing in Grafana, and then finally this Prometheus operator, which is going to be used to capture the metrics. Okay, first I'll have a quick look at the examples themselves. So the order manager first. So as I said, it's a simple Spring Boot application, REST application. So there's nothing out of the ordinary here. If I look at the controller, this shows the REST endpoints, of which there's 3. They all basically have a random delay in them just to make some of the metrics more interesting. The next line is basically accessing the OpenTracing tracer to set what's called a baggage item. Baggage is an OpenTracing concept that's used to allow an application to carry additional application-specific information along with the trace context to any subsequent services that are called in the chain. So in this example, what we're doing is we're setting a baggage item called transaction. So we're using it to say to let other services in the chain, further down the invocation chain, know in what business context their service is being called. So in this particular endpoint, we're going to set the transaction to buy. In the next method, we're going to set it to sell, and in the final method, we're not actually going to set this particular baggage item. All of the methods call the account manager. The only difference with the fail one is that it uses an incorrect URL, so that's obviously going to fail. So it'll introduce some error information into the tracing. The other couple of classes in each service are to do with configuration of Prometheus and OpenTracing. So the Prometheus one identifies which endpoint that Prometheus should get the metrics from. And then the OpenTracing, so this method would return the tracer. The OpenTracing tracer is resolved using this mechanism, the tracer resolver. So that would load the Jaeger OpenTracing client in this case, and then this mechanism here decorates the tracer with some metrics capabilities, and then this is establishing the reporter. So what adapter we're going to use to basically send the metric information. The only additional thing about this is what we're doing is we're setting an additional custom label here based on baggage. So what we're doing is we're saying all the metrics should be reported with this additional baggage label, and the label it should use is transaction. If it can't find a value, then it'll use this as the default. So this means what we can do is we can capture the service application metrics, but they'll be categorized based on the business transaction in which they're being performed. And then the other thing to do with the configuration, because Prometheus is going to be collecting the metrics on the metrics endpoint, we want to tell the tracer to ignore that particular endpoint, otherwise we'd be continually recording tracing information related to that endpoint as well. Okay, and then the account service is very much very similar. So the tracer configuration and Prometheus configuration are the same. So the main difference is the REST endpoint that it's presenting. So again, we just got some simple delays, but also we've got some randomness in there as to whether or not to create a business exception. So it's just going to say failed to find account. Okay, so if we go to the dashboards now, I've had a simple script running in the background just generating some requests to the order manager. So if we go to the Jaeger UI, so if we look for some traces, so we can see that this particular trace shows an error situation. So if we open it up, we can see that the order manager endpoint has returned a status of 500. but we could drill down and actually go follow the trace through the different services. So this span here is representing the call to the account manager. And then if we open up the account manager, it shows that it returned the status 500 as well, and there's some log messages. So in this case it says failed to find account. Okay, so that's the tracing side, but the other point about this demo is that we're using the same OpenTracing instrumentation to capture metrics. So in this top graph we're capturing what are called span counts. So that's the, if you look at the description here, you can see that we're capturing span information related to the operation that was performed, the service, and the span kind. Span kind represents, so if it's the span that's representing receiving a call into the service, then that's the server span kind. If it's like in this case where it's representing a call outbound to an external service, then it's a client span. So that's the count. We're also tracking the duration, so if any particular call takes a long time, we'll be able to see additional spikes here. And then at the bottom we're identifying the ratio of errors to successful spans. So that can also give an indication of where maybe a service is starting to go wrong and there's an increase in the ratio. But also just to show that, so these are just doing general aggregations of all the information captured from all the services and all the transactions. But we can filter it more specifically. So we could say we're interested in the sell transaction, for example, and maybe just on the account manager service. So if we add this, so it means we can narrow down the metrics that we're looking at to an individual business transaction or to a particular service or a combination of both. And also similarly, because we're capturing information from potentially multiple instances of a service running in different instances of pods, what we could do is, so if we say by pod, we could also look at the activity that's occurring within each individual pod, and we could further narrow that down by other criteria. So it means we could see which part of the system's been overloaded. Okay, so the main points that I hope that I've been able to demonstrate is that just by doing single instrumentation, using OpenTracing instrumentation of the services, we can not only capture the tracing information, but also capture application metrics from those different aspects or different parts of your service. And the other point is that the tracing information is captured separately from the metrics. So even if the tracing system is using a sampling technique, so that it may only be capturing 1 in every 1,000 traces, it doesn't mean that the metrics won't be collected for every single related to every single invocation of the service. And then finally, the ability to customize the labels on the metrics, as we showed, you can add the transaction label, but also using something like the Prometheus operator, you're being able to, it automatically labels the metrics being captured from the services with the service name, the pod, and various other details, which means it's easy to then analyze the data in any particular way that you need to. Okay, thank you for watching.